Hello, Algebra 1 CP students. Hopefully you're having a great day so far. Today, what I'd like to do is continue and wrap up our conversation on applications of linear functions. We've really taken a look at two of these problem types so far, and today we'll just be practicing those same two. We've looked at problems where it actually gives you a rate and an initial value that you're able to fill in for your slope and y-intercept respectively. And we've taken a look at problems where we actually have to do a little bit of work to find what that slope is, what that y-intercept is. But then once we have them, given data points that we can use, then we can go forward and solve any problem that's asked of us. So I want to just briefly review one of each problem type with you. Then I have two problems that I'd like you to try on your own. So pause the video at that point, try on your own, and I'll go through them at the very end of class today. All right, so starting with this first problem, I mentioned that we were given two problem types. This one is the former, in which we're given an initial value and a rate, and we should be able to build our y equals mx plus b, our slope-intercept form function, pretty quickly. It starts by saying a video game rental service charges a $20 membership fee and $2.50 for each game rented. Part A says write an equation in slope-intercept form to model the scenario. Remember slope-intercept form, our good old y equals mx plus b, right? And so here, remember that b, the y-intercept, is sort of the one-time initial fee that's assessed to customers in this particular scenario, and that would be this $20 membership fee. Regardless if I rent 5 games or 50 games, I'm just going to pay that $20 membership fee. So this plus 20 doesn't need a variable attached to it. It's not a variable change. It's just a constant. I always have to pay $20. However, this $2.50 fee is variable in that it changes depending on how many games you buy. If I buy one game, well, I only have to pay $2.50. If I buy 2 games, now I have to pay $5, $2.50 times 2. So that's why it fills in for the slope, because it's the rate at which the price is going to change. We can say it's 2.5x to represent $2.50 per game. And now our y equals mx plus b function is created. It means the total cost that it would take, the output of how much it would cost to enroll in this rental service, is equal to $2.50 times the number of games you rent plus $20 membership fee. All right, hopefully that makes sense as to how we constructed that. Part B then and Part C actually use this equation to now answer some questions. Part B says, if Joey decides to rent 15 video games, how much will he spend? Well, we know that the number of video games is x, whereas y is the total cost of doing so. So I'd be able to just say y is equal to 2.5 times 15 plus 20. And then just doing a little arithmetic with our handy-dandy calculator. I'm looking around for it. It's right here. We should be able to say, well, what's 2.5 times 15? That's 37.5 or 37.50 plus 20 means that we're going to be spending a total of $57.50. Seems like a lot, but hey, new games are $60 a pop, so that's not actually that bad. But notice how we just had to plug in 50 for x, right? Because x was the number of games. Part C is kind of the opposite, where it's saying Natasha paid $67.50 for this service last month. How many video games did she rent? Well, now it's telling us the total cost. It's telling us the output of this function. We'd have to say, when does 67.5, or really I have to say 67.50, when is that the result? When does that equal 2.5 times x plus 20? We have to find how many games would I have to pay $2.50 each for to result in that total cost. And that's just a little bit of algebra. I would subtract 20 from both sides, minus 20. We would get that this is $47.50 should equal 2.5x. And now we can go ahead and just divide both sides by 2.5 or 250. And if I do that, turn to the calculator, we can do 47.50. Sorry, it's a little dark. Right there, you should be able to see it a little better. 47.5 Trying to find that right spot. Divided by 2.5, we get 19. And so that would mean that we rented 19 games. All right. So that was a pretty brief overview, but hopefully that's a nice breakdown of how these types of problems work. We're given the slope, we're given the y-intercept, which is the rate and the initial amount respectively, and we can plug those in and work with those. All right. The second type of problem that we've seen is a problem where we're given two data points, two pairs of information, and we have to actually build our y equals mx plus b equation from that by first finding the slope and then finding the y-intercept. I'll go through this quickly with you. It says, a paddleboard rental business charges an initial cost as well as an hourly fee for renting a paddleboard. One customer rented a board for 3 hours and paid $110. A second customer rented a board for 5 hours and paid $150. So notice we're given two pairs of information. We're given one pair that says a customer rented a board for 3 hours and paid $110. I'll do my work down here. Let's make that into, let's do some work down here to give myself a lot of room. Let's make that into an ordered pair. I have 3 hours and paid $110. Just like that. Okay. The second pair of information here is that a second customer rented a board for 5 hours and paid $150. So let's make that our second piece of information right here, our second ordered pair. If we rented a board for 5 hours, then we pay $150. Now, with those two ordered pairs, those two pieces of data, I can go ahead and try to build my y equals mx plus b function. First, let's find the slope. We'd be able to say here that the slope is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. It's a change in y over change in x. And I'll just label those for you. That's x1, y1. That's x2, y2. So let's plug this in and see what we get. We'll get that that's 150 minus 110 over 5 minus 3, which tells us this is 40 divided by 2, or 20. And so we're able to fill in our function so far by saying y equals 20x plus b, but I don't quite know what that b is. The 20 would represent that hourly fee for renting the paddleboard, but the b, the initial cost, is still unknown. So in order to figure it out, let's use these pieces of information, plug this in for x, plug this in for y, and see what we get. Ready? To find this b, let's say to ourselves, you can pick whichever piece of information you want. I'll pick the first one just because it looks a little easier. That 110 should equal 20 times 3 plus b. That means that 110 should equal 60 plus b. And if we subtract 60 from both sides, that tells us that b would equal 50. And so since we know that b is equal to 50, that means that initial cost is $50, and our function would look like this: y equals 20x plus 50. All right. As I mentioned in class, for those of you that were in class on Tuesday, I mentioned that these problems aren't really any different from problems we've done before. We have done problems where, given 2 points, your job is to find an equation in y equals mx plus b form, in that slope-intercept form, that passes through them. The difference now is that it's just tied to a scenario. But really, it's the same type of problem as given 2 points, find the slope, which we know how to do, and then given that, find the y-intercept, which we know how to do by just plugging in one value for x, one value for y. So the equation here is y equals 20x plus 50. Now that we have that, we should be able to solve these other questions pretty quickly. We know, as I kind of mentioned to you as I was talking, the slope represents, I'll say here that the slope is the hourly fee, because that's, you know, how much we pay is going to change based on how many hours we rent the paddleboard for. That's why we need this variable here to represent the number of hours. And that 50 is our y-intercept, which is our initial cost. one-time fee of $50 regardless of how long we spend on the paddleboard. Last but not least, just answering this question, how much should a customer expect to pay to rent a paddleboard for 12 hours? So we can say we don't know how much they're paying, but we do know that they're spending $20 an hour on the paddleboard for 12 hours. So we plug in 12 for X. And we can solve this pretty quickly by saying 20 times 12 is what, 240 plus 50. And so they'd be expected to pay $290. Okay. Hopefully that makes sense. I tried to give a brief breakdown of those two problem types because now what I would like you to do is, given two of these problems, notice no breakdowns, no part A, B, C to try to break things down for you. This is just real deal problems you'd see on an assessment. See if you can pause the video at this point, try these problems on your own, and then I'll pick right back up and go through them with you. Okay, by this point, I assume that you've paused the video, tried these problems on your own. Hopefully you're able to get an answer, but let's go through them together. First problem you hopefully noticed is one just like the one we did, where we have two data points, two ordered pairs, and we can build our equation from that. This says Jack has a smartphone. He had to pay a certain amount for his phone up front, and then a monthly fee to continue using the phone. After 10 months, Jack has paid a total of $850. Let's stop there. Let's say that's our first ordered pair. 10 months, $850. Next, after 12 months, Jack has paid a total of $980. Second ordered pair. If we had the phone for 12 months, then we had to pay $980. How much will Jack have paid when he owns the phone for 18 months? So before we can answer that question, we first have to build an equation in this y equals mx plus b form. Well, we have 2 points, so we should be able to do that pretty quickly. x1, y1, x2, y2. Let's say that our slope is equal to y sub 2 minus y sub 1, change in y, over x sub 2 minus x sub 1, change in x. That's going to be 980 minus 850 divided by 12 minus 10, which is, let's see, 980 divided by 850. Minus 850. I think I said divided by. My fault. 980 oh my gosh, I can't even talk. And I can't even do math correctly. Holy shkamoli. Calculator. It's that kind of day. 980 minus 850. Bam, we get 130 divided by 12 minus 10. I shouldn't need a calculator for that. That's 2. And 130 divided by 2 is 65. Okay? So that means that our slope, our monthly payment, is $65. So I'd be able to start by building my equation to say y equals 65 times x plus b. I don't really know what my b is yet, but I'm going to find it. And I'm going to find it by using one of these ordered pairs. We could pick whichever one we want. I would pick the first one personally because it looks easier. I'd say 850 should equal 65 times 10 plus b. Right? Don't be scared by the large numbers. That means that 850 would equal 650 plus b. Subtracting 650 from both sides, we would get that b is equal to 200. And since we know that b is now equal to 200, you can sub that back up there and say that y should equal 65x plus 200. And now that we have our equation in slope-intercept form, this is our monthly rate, this is our initial payment up front, we can now figure out how much will he have paid when he owns the phone for 18 months by just substituting 18. We'd be able to say y should equal 65 times 18 months, $65 a month for 18 months, plus 200. Which means that y is equal to, let's see here, 65 times 18 is 1,170 plus 200, which means ultimately that we're going to be paying $1,370. That's how much Jack has to pay for 18 months, a year and a half. Okay? Last but most certainly not least, problem number 4. Again, hopefully you figure this out on your own. Hopefully you also recognize that, this problem is nice in that it gives us a rate and it gives us an initial amount right away, which is great. So we start by saying y equals. Our initial water level here, it says suppose that the water level of a river is 34 feet, and during a drought, it is receding at a rate of 1/2 of a foot per day. In how many days will the water level be 26 feet? So it gives us an initial amount that we're starting at 34 feet. So I'm just going to put a plus 34 right over there. Now, I guess it's not really even a trick, but I guess the kicker with this problem is the fact that this water level is receding at a rate of 1/2 of a foot per day, meaning it's getting lower. It's going down, right? So the fact that it's receding means that my rate would be negative 1/2 times x. Okay, my rate would be negative 1/2 of a foot per day because it's receding. It's not increasing. It's not going up. It's going down. The water level is getting lower. The water is evaporating in the drought. So now that we have our function, you'd be able to say in how many days will the water level be 26 feet? Well, we're trying to figure out when the height is 26 feet. We have to figure out how many days that's true for. So, or how many days makes that happen. 26 should equal negative 1/2 times x, which we don't know again how many days. That's why we leave x there, plus 34. Trying to see for how many days, in how many days rather, should I expect the river to be 26 feet in depth. So a little bit of algebra here. We would subtract 34 from both sides. We would get here that negative 8 is equal to negative 1/2 times x. Now, in order to get rid of negative 1/2, you could divide both sides by negative 1/2 or multiply both sides by negative 2. Either way, you're accomplishing the same thing. Suppose I write divide by negative 1/2, divide by negative 1/2, or I could write multiply by negative 2, multiply by negative 2, both the same operation. We would get here that x would equal 16. Okay, meaning that it would take 16 days for the water to get to this threshold. Okay? Hopefully those word problems made sense. Again, I think it was worth it to take another day to really revisit those and do a deep dive to make sure we fully understand single equation, single variable, linear equation word problems, y equals mx plus b, before we delve into the world of systems of equations, which is coming your way pretty soon. All right? Thank you everyone so much for your attention and focus. I hope you have a great rest of your day, and please feel free to contact me with any questions. Take care.